Got in SPC, stable process, unstable process, capable process, not capable process, and what mistakes we do, and how to analyze the problem separately. I told we need to have different strategy for the common cause, different strategy for the special cause. So let us understand common cause and special cause. Tool wear out is a common cause or a special cause? Common cause? Special. How many say common cause? How many say special cause? Okay. And both the answers are incorrect because we cannot say just by the name of the cause it is common or special. If tool wear out is natural, that perturbation is always there as a common. Sudden excess tool wear out, it is a special cause. Suppose traffic while coming to the office there is some traffic which is creating variation in reaching time. Is common cause or a special cause? Special cause. We cannot say that because traffic is affecting every day. Maybe someday 10 minutes, someday 5 minutes, someday 15 minutes. That much variation traffic every day creates. There is a common cause. Suppose that much variation is common cause. Suddenly there is an excessive variation in your arrival time because of one particular day something happened. Then that is a special cause. Just by hearing the name traffic jam or traffic is not a common or special. So we need a control chart for that to say common or special. So we cannot say just by the name of the cause whether it is a common or special. How much impact it makes, that only can tell common or special. Important thing we need to understand is process cannot understand specifications. See, for example, I will drop these cards. I will try to drop the card exactly one over the other. Is it falling exactly one over the other or whether there is a variation? There is a variation. I am trying to drop exactly one over the other, but there is a variation. And this much variation is there. If I say this is my specification limit, then parts are going outside the specification limit even though it is due to common cause. Getting my point? Yes. If my specification limit is this much and now all are within the spec. Even sometime if there is a special cause, it may still be within the spec. So common cause or a special cause cannot be identified just by seeing whether parts are within spec or outside the spec. Process cannot understand specification. Process cannot think this is the export customer, so we should have less variation. This is local customer, so we can have little more variation. Process cannot think all this. Process will create some inherent variation. That may be due to common cause. Sometimes there may be special causes. So let us understand. If I drop these cards, say I'll drop, just observe 1, 2, 3. I'm just dropping the cards. There's a variation happening. There's a variation. I'm trying to drop one over the other. There's a variation. What did you observe in this process? In this operation, what did you observe? There is some special cause. I have not given any specification limits. Even without specification limit, you can say that there is some special cause which is abnormality. Suppose card is here and next card is here. There is some variation. If you ask why there is a variation, you cannot give one reason. Because it is due to common cause or chance cause. But assignable cause or special cause affects one particular data. So special cause you can assign the reason. If you ask me why that card has fallen there, see I am dropping like this, like this, like this, like this. I can assign the reason. It touched my finger like this and it has gone there while dropping. I can give why that card has gone there. I can assign the reason. That's why it's assignable cause or a special cause. Special cause can be eliminated Common cause cannot be eliminated. The special cause, if it is there in the process, we say process is unstable. Process is out of control, not statistically in control, out of control. Special cause is there, unstable process. If our problems are due to this, our entire method of problem solving is a different strategy. You getting my point? If problems are due to special cause like this, what we should not do and what we should do. If the problem is due to common cause, what we should do and what we should not do. Our method of doing is different. Solving problem is different. Say for example, I'll give this is the specification. This is the specification. I need to draw within this specification. It's my spec. So I'll try to draw in the spec. Oh, thoda, slightly it is that side. Remove here. Oh, this is becoming a little more, like remove little front. Now it is okay, okay, okay. Oh, now it has gone far. Oh, let me bring this way. Okay, okay. Oh, it has gone further far. I have to bring this way. Okay, okay. Again far. Bring this way. Oh, it has come more. Now what I am doing? I am trying to make the parts within the specification. But I cannot make it because variation is not because of my adjustment. Even if I don't adjust, even if I keep at one place, the variation is more than the specification. Even if I don't move my hand, if I keep it one place and if I start dropping, the variation is more than the specification. So what people do when the variation is more than specification, oh, it has gone up, adjust it, reduce this, increase this. They keep changing the setting. So when I adjust like this, without even adjusting, variation is more than spec. If I adjust, what will happen? Variation will increase or decrease? Increase. It has to increase, no? Because see, if I keep like this, it is making this much variation. Along with this, if I start moving this, what happens? Variation will increase. So Deming criticized many of the companies because they are not able to understand this. They keep on adjusting the process to reduce the variation, but that adjustment, if it is done for the common cause, it will increase the variation. It is called over adjustment or type 1 error. We cannot solve the problem of more variation than spec by adjustment. If you start adjusting, it will create more variation. It will create over adjustment. So these kind of, in this case, if you see this, variation is more than the specification. But there is no any special cause. So this process is a stable process but not capable process. Let me show you all the 4 situations. There are 4 situations. One is called not stable, not capable. Not stable, not capable. Or a process may be not stable, not capable. Okay. Situation 1. Not stable, not capable. Not stable means what? Not stable means there are special causes. Not capable means what? Out of spec also. So let us see. This process is called not stable and not capable. It is not stable because there is a special cause. There is a special cause. What kind of action is needed in this particular process?
First make it stable.
First make it stable. That means first I have asked the question, what is changed during this time? Only ask that question. What special thing happened during that time? What something happened, abnormality happened this time? Ask that question. And then find out the reason. Don't worry about all other readings. Just ask what change happened only during that time. Like he was saying, my casting rejection suddenly came in 1 month. That is due to special cause. We have to plot IMR chart or we have to plot the chart, then we will come to know. When suddenly it comes, it's a special cause. If the special cause is there, we should ask the question, what change happened during that period only? You should not take all of the readings. What change happened during that time? And take the action. Now, when you use a control chart will give you control limits. It is not based on specification limits. Because you know already control chart formula. What is the formula? X double bar plus A to R bar, X double bar minus A to R bar, wherein nowhere we are using specification limit. R bar is based on process variation. So control limits are set. Control limit is voice of the process. It is set based on your own process variation. So your process says, my common cost variation is this much. That is control limit. It is not specification limit. My common cost variation is this much. So when I am making this much variation, please do not touch me. Please do not adjust me. I am running normal condition. I am here, please don't make anything change. This is normal. This is my regular variation. That's what control chart is telling. When sudden point goes out of control limit, it is saying something. That please look at me, some abnormality happened. What happened? Please correct. We have to listen the voice of the process. Process is telling us something in the language of control chart. We need to understand whether there is a common cost or a special cost. If there is a special cost, take action at that point of time. What has gone wrong? Why that data is different? But what mistake we do, if it is due to common cost, it is due to out of spec. Out of spec may be due to common cost. Out of spec may be due to common cost. Actually, if it is due to common cost, it says do not adjust. I am due to common cost. But you adjust, it will create more variation. Because you should not adjust for the common cost. So this process, when it is not stable, not capable, first is take action on the special cost. So let us, if I show you this slide, the difference between common and special cost, if you already know, let me just show you this one. Just look into this slide. Not stable, the SPC slide. Not stable, not capable. Not stable. That means there is some special cost here. There is some special cost here. This is the control limit, not the specification limit. This is not stable and also not capable. Variation is more than the specification limits. If you see Professor Hitoshi Kume's book, Statistical Methods, he has explained it very, very nicely. And if you see SPC, AIAG manual, second edition, it is explained very nicely how to understand these four situations. Right? Now, this is not stable, not capable situations. Action required is, we need to ask what is different in this place? What is different in this place? And take action only for that. Don't worry about this variation. This is due to common cost variation. We have to deal like that. Suddenly one day rejection comes. We have to only ask one day what has gone wrong. Right? Suppose rejection is consistently coming. 0.2%, 0.15%, 0.23%, 0.25%, 0.15%. Suppose it is consistently coming. Then it is a stable cost. We have to work on reducing the common cost using design of experiments, analysis of variance, and all such things. In this case, we have to apply special cost strategy. In this case, we have to apply common cost strategy. Right? What is the ultimate aim of SPC or your Six Sigma project? What is the ultimate aim? To reach this stage. What is this stage? Stable and capable process. So you have seen two situations, not stable, not capable. First situation. Second is after you take action on special cost one by one. Special cost come, root cause finding, corrective action. Special cost come, root cause finding, corrective action. After taking such actions, you may move stable, capable. Stable, not capable. Stable, not capable, like this. What is this? Stable, not capable. You may reach this situation. If you reach this situation, now this requires common cost strategy. You should not ask why this one is different than this one. You should not ask because there is due to common cost. So, this is a good project to work with. There can be another thing called stable, not stable but capable. What do you mean by not stable but capable? Not stable but capable. That means say you have larger spec. Say your spec is, maybe this one is your spec. So your specification is larger. When your specification is larger, and I try to draw within spec, within spec, within spec, within spec, within spec, within spec, all are within spec. Suppose process is changed. Okay, suppose it still falls within the spec. Now what we say?
Being shifted.
No problem, within spec, na? It is within spec, so no problem. It means even though there is a assignable cost or mean shift or special cost, we treat it like common cost. Don't touch anything within spec, do not touch anything. It is within spec. Then we are doing type 2 error. Treating special cost as common cost is a type 2 error. It also increases the variation because this can be eliminated. This can be eliminated. Why this needs to be eliminated? If process is unstable, you cannot predict the rejection. You already learned how to predict the rejection using Z table. That prediction is valid only for common cost. If this kind of special costs are there, then prediction becomes invalid. So customer always wants a predictable process, consistency. So we need to eliminate the process special cost and bring the process under stable condition. If it is like this, you ask why it is different, why it is different, why it is different. Then take action so that we move to this condition, stable capable condition. What is the stable capable condition? Fourth case, this is spec and I draw, sorry, this is spec. So now you can see it is stable, variation is consistent, and of course it should be within spec also. If the variation is consistent and within spec, then we say it's a stable and capable process. Aim of SPC, statistical process control, is to achieve stable and capable process. So just to summarize what we learned about common and special cost, you can see this slide. You look for what was different between individual points. Matlab, one point has gone there. You look at individual point. What is different in this individual point? If you look like that, if it is due to common cost, you are wasting your time. Suppose yesterday I reached at 9 o'clock, today I reached 8:55. If it is the variation is due to common cost, why there is a difference? Why I reached today 5 minutes early? If you ask the variation is due to common cost, then you are wasting your time. And based on that, okay, yesterday I reached 9 o'clock, today I reached 8:55. It means I should start 5 minutes late from the home. Whatever time I started today, because I am unnecessarily coming 5 minutes early, I should start 5 minutes late. If I take action based on that one reading, which was due to common cost variation, then we increase the variation. If one point is different from other points, if it is due to common cost, you adjust based on the difference, you increase the variation. And if one point is different than other point, you ask, when we were doing SPC implementation in ACC Cement, the plant head, MD, Mr. Banerjee, he told all the plant heads, if you are coming for any capital equipment budget, come with control charts. He told very clearly. Because people are saying that plant is having this wave feeder, they are having this auto sampler, we do not have, we need this investment. He said, if you want any such investment, you have to come with control charts. Do you know why he said that? He was very clear in SPC concept. Because if it is due to special cost, something is going out of specification, you don't need any investment, you have to only make special cost correction in your process, that's all. You don't need. Okay? All these actions are possible when process is stable and process is capable. Now what happens if the process variation is close to tolerance? Say for example, this is your tolerance and your 6 sigma is close to tolerance. Then what should we do? Now say your PP value or PPK value is close to 1. Close to 1 means say 1.1, or maybe 0.9 or 1.2. It is not more than 1.33, suppose. Say your ppk value is 1.1. What should we do? First thing is, we have to now live with 100% inspection. We have to live with 100% inspection. Because there is a possibility that it will give some rejected parts. So it is extremely important in that situation that we control the process through 100% inspection. First action. Second action is reduce the variation. So in this situation, do 100% inspection. One action. Second action is reduce the variation. Reduce the variation. Third action. Every time you have to be very cautious about your setting. So just to have a quick recap, you must apply this in your